There's a little story I like about the Chinese philosopher Zhuangzi, one of my favorite writers in the whole history of the planet. In the story, Zhuangzi wakes up from a dream where he's a butterfly, except he says now he can't remember if he's a man dreaming he was a butterfly or a butterfly dreaming he's a man. Now, this story gets at some of the most fundamental questions about human consciousness. How do we know for sure when we're dreaming and when we're awake? What are the differences between those two states of consciousness? What might they be able to tell us about the nature of consciousness itself and about the unconscious mind? Now, the researcher who's joining me today on episode 16 of the Connectome Podcast has been fascinated by exactly these questions all his life. He's also fascinated by depth psychology, Jungian symbolism, and psychedelic drugs, and equally by data-driven neuroscience fields like functional connectomics and magnetic resonance imaging. He's a doctor of neuropsychopharmacology at Imperial College, London, and he recently made headlines for conducting a study in which he gave people LSD, then scanned their brains in a cutting-edge modern fMRI scanner and mapped how their brain connectivity changed while they were on the drug. I am, to say the least, very excited to have this conversation. Robin, thank you so much for coming on the show today. I'll just jump right in. How did you get into the idea of studying the brain on LSD?
It's always tricky to know where to start, really, but I think really it started for me, funnily enough, when I was studying psychoanalysis, so not neuroscience at all, really, although I was interested in neuroscience. But I was reading some popular science books. I was reading the likes of Alan Hobson on dreaming. I read an interesting book called The Dream Drugstore by Alan Hobson about dreams and altered states of consciousness, and talking about the possibility that the LSD state may share some similarities to the dream state. And I thought that was a very interesting idea. Really a sort of key text that really got me excited and gave me a sense of direction was actually Stanislav Grof's Realms of the Human Unconscious. In a way, that's more captivating as just a single book than reading something like a Carl Jung book, potentially. And the contents of the unconscious are so visible, at least in the account contained in that book. But after reading Stan Grof's book, I knew what I wanted to do, and that was to do research with LSD, particularly LSD. At that stage, for me, it wasn't psychedelics in general. The focus was on LSD. And then I wanted to do brain imaging, and at this point, I didn't have any formal neuroscience background. I certainly didn't have any experience with brain imaging or fMRI. Well, I did a library search. I found a name, this researcher called Kelly Morris. I contacted her, and the other person was David Nutt. And so I went to see both at pretty much the same time. So I had this interview with David. David, at this time, wasn't really that interested in psychedelics. That was the sense I got. I told him I wanted to do this fMRI study. I told him I had an idea that the brain in the LSD state may share similarities with REM sleep, dreaming. I kind of put a sort of psychoanalytic slant on things and said that this could be used as a way to sort of develop an evidence base for the existence of the unconscious mind. Freud had a hypothesis, really, that's all it was, that dreams are a special way of accessing unconscious material. And people have said the same thing about LSD. So let's look at the biological underpinning, then maybe we can say with more confidence that there are similarities in the psychology and that they rest on something solid and objective, David heard me out and he sort of said at the end, you can't do your LSD fMRI study. And then he said, well, why don't you talk to my colleague, who's a sleep researcher, and see if there's something else you can do. But I talked to his colleague, this Sue Wilson. She told me she's interested in sleep and serotonin function and whether sleep can be used as an index of the health of the serotonin system. And we could look at MDMA users and matched healthy controls and see if MDMA users have abnormal sleep, and we could do something called tryptophan depletion. You might be familiar with it. To effectively reduce serotonin in the brain, and use this as a kind of probe to look at any differences in the sleep of MDMA users. So anyway, that ended up being my PhD. It was a self-funded PhD. There were some sacrifices there. Amanda Fielding was still around, head of the Beckley Foundation, and was still interested in some research happening with psychedelics. And I was in the right place at the right time. I wrote a protocol. We took it to an ethics committee. David came with me. We got it approved. We had Amanda's money, and we had the facilities, and we did it. So we did a pilot study, first of all, just getting a kind of dose-finding exercise, really, with psilocybin. Psilocybin being, of course, magic mushrooms. And then we did shortly after we completed that, we did an fMRI study, and this is still 2009, I think, 2009, 2010. Things have sort of developed from there, but that's a kind of, that's my account of the beginnings of things, really.
It sounds like we got into neuroscience in really similar ways, Robin. I'm a big fan of Stanislav Grof's books, and one of my biggest neuroscience questions is, what's the difference between being awake and being in a dream? What's the difference between an awake state and a dream state? A few years ago, I had the huge privilege to do an episode of the podcast with Oliver Sacks before he passed, and we talked a lot about hallucinations. And I remember I asked him, what do you think is the difference between a hallucination in the awake state and a dream? And he was very nice about it, but he basically said, I have no idea. And so my search has continued, which is why I was intrigued as soon as I heard about your study. So let's get into the meat of it. What exactly did your team find when you examined the neural correlates of the LSD experience?
Yeah, okay. So, the LSD study came off the back of similar research with psilocybin and also MDMA. But the LSD study, given that you get a longer duration of effects when you give LSD relative to psilocybin, it enabled us to use more than one imaging modality. We had people go in the MRI scanner during the peak effects, and then they went in the MEG while the effects were still present but somewhat attenuated. And so we could use these different modalities in a complementary way, where fMRI has limitations in terms of its temporal resolution, MEG can fill in, and where MEG has limitations in terms of its spatial and depth resolution, fMRI can fill in. So I suppose, there are some principles that have fallen out of not just our work with LSD, but what came before with psilocybin in terms of how psychedelics seem to work in the brain. And one way to describe this is to talk about, and sometimes to describe this, I've talked about what happens in the brain during normal development. So, for example, intrinsic, or as other people call them, resting state networks, develop in integrity, so the strength of the functional connectivity and also structural connectivity between the regions or nodes that make up these intrinsic brain networks strengthen as we develop and as we mature, and that seems to mirror developmental changes as well, like the acquisition of a sense of self, for example. That would be quite a high level aspect of it. Not only do these networks seem to develop in integrity, they also seem to segregated from each other. And so one way to think of what psychedelics are doing based on our data is a kind of reversal of what happens in the brain during normal development. And what we got with the LSD data was some impression of how comprehensive this disintegration effect was. So based on our psilocybin work, we were thinking it might be restricted to a couple of important brain networks like the default mode network. When we did the LSD data analyses, we really did it in a much more comprehensive way, looking at something like 10, maybe 12 canonical brain networks. And then we looked at their integrity, their functional integrity. We looked at signal variance, which is related to the integrity of the networks. And we looked at change in blood flow in these networks. And really, a clear effect was that there was really quite a comprehensive decrease in the integrity of these brain networks under LSD relative to placebo. So the opposite of what you see in the brain as the brain develops normally. So we were seeing the opposite under LSD. Then if you look at the way the brain networks relate to each other in terms of functional connectivity, so how strongly they're communicating with each other, we found that under LSD they were communicating with each other much more openly or freely, or there was simply much more communication. We did that analysis we expressed it in a correlation matrix showing pairs of brain networks and expressing the change in their connectivity strengths via a color, essentially. So red being an increase in the strength of the communication. And so break that right down, we're seeing a kind of desegregation effect in the brain with LSD, very similar to what we'd seen previously with psilocybin. An interesting question is whether these kind of effects are exclusive to this class of drugs. Maybe if they are key aspects underlying the way these drugs profoundly modulate consciousness, then given that psychedelics are relatively unique in how they profoundly alter the quality of waking consciousness, then maybe if we were to look at other drugs, we wouldn't see these effects. And I'm unaware of any other studies with any other drugs that have shown effects, at least of this magnitude, that we've seen with psilocybin and LSD on these two metrics. So just to summarize it in a couple of words, really, what we're seeing essentially is brain network disintegration, but also desegregation. I quite like those terms, and they can kind of work. I mean, one of the challenges when it comes to communicating this research to a broad audience is to think about how can I express these results in a language and in a way that people are going to get, that a lot of people are going to get. And so one thing I like to do is to think carefully about valid metaphors. It's quite nice when thinking about brain networks to think of other networks, in the world. I've talked about, in terms of disintegration, there are a number of different analogies that you could use, but you could talk about the breakdown of a political system, for example. If there's some kind of coup or whatever, the integrity of a system, let's call it a country, it breaks down. Let's use the example of something like Iraq, with the invasion of Iraq, and you take out the key sort of command centers and control centers, the hubs, if you like, and then the system disintegrates. What you're left with is a kind of disorder, but it's not entire disorder. You get some interesting, consequences of the chaos that's been introduced, in that you get the emergence of some anarchy, some sort of spontaneous, primitive signs of sort of reformation or reorganization. But also, so that would be disintegration, the breakdown of a country, say. If you think about desegregation, if you Google the term desegregation, what you come up with is racial desegregation. And that metaphor can be quite useful as well, in a way. If you think of sort of racial mixing and blending and less of a differentiation between things that were otherwise separate. I mean, it sort of makes sense in a slightly provocative way around the idea that psychedelics may affect things politically as well, in terms of ideas around, one world, union, movement towards sort of improved integration on a sort of global scale. I just think it's interesting to play with these ideas that maybe changes in the brain through a little chemical, a molecule could change the system, the brain, which underlies behavior. And when people interact and they develop social networks, maybe these changes could stretch as far as the way people interact with each other, and stretch as far as sort of communities, maybe societies, and maybe sort of political perspective and all this kind of thing.
So large groups of people who've had these kinds of experiences might interact differently than people who haven't, which could actually influence social dynamics on a large scale. That's actually not as odd as it might sound. I wrote an article a few months ago for Discover magazine about a brain parasite called Toxoplasma gondii, which you've probably heard of. It lives in the bodies of cats, and it tends to infect humans when cats scratch them. And it can produce symptoms that are similar to those of schizophrenia: disconnected thinking, dangerous risk-taking behavior, stuff like that. And here's the really scary part. Most Toxoplasma infections sit dormant for years without producing any symptoms, until one day the parasite wakes up and starts driving the host literally crazy. Some experts estimate that as much as 30% of the people on Earth, more than 2 billion of us, are infected with Toxoplasma right now and don't know it. Maybe even higher in areas without great sanitation and healthcare, like developing countries in the Middle East and Africa. And researchers have actually asked, this sounds pretty out there, but there have actually been research papers on this, because we know for a fact that this parasite exists and that it's living in huge numbers of people right now. Researchers have actually asked, what kind of effect might that be having on the politics of these war-torn regions? If 30% of the population or more are infected with a brain parasite that's making them prone to delusions and hyper-aggressive behavior. And it sounds pretty far-fetched, I know, but just think about it as a hypothetical, as a thought experiment. If the instability we're seeing in a place like, as you said, Iraq, could have something to do with a brain parasite, could it be possible to create changes in the other direction on a large population size scale by giving people small doses of LSD? Again, pretty far out there, but you've got to admit it's an intriguing question.
They're really interesting questions, aren't they? Because, ultimately, societies and systems and politics and they all depend on people. Governing people and their behavior is, as far as we're aware, it has a lot to do with the brain. And sometimes subtle changes in the brain with a drug can have profound effects on the way we think and behave. And so that's gonna filter through. Granted that we're talking about the acute state there with LSD, but the interesting thing about LSD and other psychedelics is that they don't seem to just modulate people while they're under the influence of the compounds. There seems to be something lasting. There seems to be something enduring. It's a very, very interesting research question as to whether there's a biological basis to these apparent long-term changes in thinking and behavior that you can see after psychedelic experiences.
And it's true, lots of studies have found, and individual people have reported too, that an LSD experience leaves them with a permanently altered perspective on the world, with a deep sense of calm and a sense of connectedness. So that covers the large-scale and long-term effects, but I want to actually break down what you and your team found in your study. In the paper, you say you had two main findings. The first one was that the visual cortex, the brain region that processes visual imagery, got hyper-connected and hyper-communicative with other brain regions under the influence of LSD. Yeah. It started sending visual input to all kinds of other brain areas that it doesn't normally talk to. Now, do you think this could be similar to what's happening when we dream?
I do, and one of my frustrations is that it's not easy to do dream research, and I'd love to do it personally. It's a bit of a shame that others haven't done it either. You know, MEG techniques have developed quite a bit over the years, and the source localization has improved. So there is a way, you know, and you can do your simultaneous EEG and fMRI. I think there's massive scope for more research on particularly REM sleep and looking at things like functional connectivity. I mean, I feel like I've slightly got my finger off the pulse in terms of fMRI and REM sleep. But to answer your question more directly, it makes sense intuitively to me that something similar would be going on during dream sleep, that there would be much more open communication going on between, say, the primary visual cortex and other perhaps non-visual areas in the brain. That's an open question. I think it needs to be filled in by someone, hopefully soon. Yeah.
I'd really like to see that question filled in too. How is it that we perceive so much intense visual imagery when we're dreaming, but we don't see those kinds of, whatever you want to call them, subconscious imagery when we're awake? And is dream imagery the same thing as hallucination imagery, or is it neurologically different? And these are questions I desperately want to see answered, because I think they're going to tell us a lot about what consciousness is and how it works. I also want to talk about the second finding you reported in your paper, which was increased connectivity between two brain areas called the parahippocampus and the retrosplenial cortex. And you think this increased connectivity you saw between those two brain regions in people on LSD may be the reason behind some of the more profound aspects of the LSD experience, like the dissolving of the self, the dissolving of the ego, and that grand sense of unification with the cosmos. Now, the parahippocampus and the retrosplenial cortex are not exactly what I'd call A-list celebrity brain regions. So how would you summarize for the people who are listening what these regions are, what they do, and what it means when they talk to each other more intensely under the influence of LSD?
Yeah, well, they're not. They might not be A-list. Maybe the hippocampus is, but it's my favorite circuit really in the brain. We had someone come and speak to our team at Imperial recently. It was Eleanor Maguire from the Functional Imaging Laboratory in Queen's Square in London, part of UCL. And she's really an authority on this particular circuit. She's found that this circuit seems to be especially implicated in these functions. I think they're fascinating functions. You know, what are we if we're not our stories? You know, we're our narratives, and these narratives been constructed, and we rest on them, we rely on them. Without those narratives, we're lost. If you have complete ego dissolution, although it might have this wonderful mystical spiritual quality sometimes in the right context, it can also be terrifying because you don't know who you are, and you can't really operate in the world that we've constructed around us. You're essentially like a helpless baby or an infant if the ego dissolution is quite complete, Or you look at something like Alzheimer's, where these circuits again are implicated, and people essentially are losing their personalities. They are losing their stories and their narratives, and they need to have that anchorage in their memories and their pasts. Otherwise, they don't really exist anymore. So I just think it's fascinating that we saw this rent, really, like this severance in this particular circuit. It just makes me intrigued about the involvement of this circuit in states like dreaming, where there is, unusual and very vivid imagery that essentially is taken as real, during the experience, and these scenes that are very complex and sometimes very vivid, and of course the emotional tone of the state. Yeah, for me, seeing that effect and seeing that circuit implicated has got me thinking that this is something really essential to the quality of human consciousness. And I think, a lot of the research on consciousness is focused on the level of consciousness, and by that really I mean the level of wakefulness. And so they'll study anesthesia and sleep and then extrapolate from there. But the thing is, are you really saying anything specific about consciousness when you approach it in that way? Because when you fall asleep, you don't just lose consciousness, you lose a whole bunch of other things, and then that and it comes back to that classic problem in the study of consciousness, in that the definition is so broad such that it's almost useless. By these terms, if consciousness is what you lose when you fall asleep, which I think Tononi might have said, then that's just everything, and it's vague and sort of unhelpful. But if you can think a little bit more carefully about qualities of waking consciousness and how you can modulate them, so not just the level of wakefulness, but some more finessed aspects of consciousness, and if you could think very carefully about what's special about human consciousness, and if we think about that, then I don't think it will take us long before we realize that it's not just language. It's something else that's fundamental about the quality of human consciousness. And I would, want to submit that it's related to this very pervasive and sort of saturating sense of having a self or identity or an ego. When you think about it in that way, then you can see the research power, really, and potential of psychedelics, because they may be relatively unique in their ability to modulate this quality of consciousness. And if, for example, we see these very strong correlations, that was one of the things about this finding was just how strong the correlation was. I know that doesn't equal a causal relationship, but it is still telling, I think. And then it leads you to ask the question, well, maybe this circuit is essential for this particular quality of human consciousness that we have, which defines human consciousness, really, and makes it something other than animal consciousness. And I think that's I think what we picked up with this finding, and is probably something quite important, that maybe it's sort of highlighting and identifying a really crucial circuit in the brain that is it needs to be operating normally and in a particular way in order for us to have this quality of waking consciousness that we have.
And if we could pinpoint that circuit in the brain, we might actually be able to pinpoint what it is that distinguishes waking consciousness from dreaming consciousness. Which, like I said, that's exactly what I asked Oliver Sacks about, that he didn't have the answer to. It's one of these questions that I'm just so eager to have answered. And that ongoing sense of self, that's one crucial difference, like you said, between animal consciousness and human consciousness. This is something I talked about with Bernard Bars, another of my favorite consciousness researchers, when he was on the podcast a few months ago. A lot of animals probably have a subjective experience of the world, but that experience may not have an ego, a self in it. One of the things that makes human consciousness so unusual and so fascinating is that it's always focused on this idea of the self, the ego, and these stories of ourselves that we're constantly telling ourselves moment by moment. And a lot of other animals may not have that ego, that story, because they don't seem to have the brain regions that are involved in things like theory of mind and self-other boundaries, sense of self. And a lot of times when people say the word consciousness, or ask questions like, what is consciousness? They don't seem to be very clear on that all-important distinction between the experience of being conscious, which is one thing, versus the sense of self on which our consciousness is centered. And those are actually, neurologically, they're two completely distinct phenomena that work together. They're each produced in different regions of the brain. We know this now. The brain regions that produce subjective experience are very ancient and date back to our earliest common ancestors with fish, if not even earlier. But the regions involved in a sense of self are much more recently evolved. These are areas like the prefrontal cortex. They may only exist, really, in certain mammals, maybe birds, maybe dolphins, most strongly by far in us and the other great apes. And that's a really important distinction between the experience of being conscious versus the sense of self, the story of the self, on which our conscious experience is centered.
Absolutely.
And this also brings us back to something we were talking about earlier, Jungian psychology, depth psychology, and the unconscious mind. You said you're curious about the exact nature of the unconscious mind. What is it neurologically? Where are its boundaries? Where can we find its correlates in the brain? You said you're curious about dreams and psychedelic drugs as possible portals or gateways between the conscious and unconscious minds. Now, of course, this is something I would really like to find out more about. What are your ideas about how to approach studying these questions?
Well, that's a beautiful question, and I wish others would sort of see its value or recognize it. And so you've got a participant in your trial, but you've also got like a next of kin. And let's say it's their mother, just to be quite psychoanalytic about it. You acquire personal biographical material from this individual about the participant that you're studying. You'll find out about their childhood, for example. Then I think you could construct some cues around conjuring up memories of one's past and one's story. And you could offer these to the individual while they're being scanned. You could also have a bunch of phony memories or cues that haven't come from the participant's mother. You've got them from someone else's mother, but you're going to throw them in anyway. Now, why would you do that? And this is a really crucial thing. Let's say a skeptic reads Stan Grof's book and thinks, well, okay, people are reporting this stuff, but how do we know it's real? It's veridical, that these things actually happened in the individual's life. could they not just be fantasy? Maybe there's some suggestion going on, and all you need to do is suggest something, and the individual will, in this kind of hyper imaginative state, is going to latch onto that and start imagining these scenarios and believing that they're true. So I think you need to test that, really, and so you need these phony memories in there as well. And so you can look at things like the emotional arousal, say. You can have things like the vividness of the imagery. That's one way to approach it, and you would be making the prediction that under LSD or a psychedelic, relative to placebo, the personal memories, so the memory cues that are real, are going to have a much bigger emotional impact. So emotional arousal will be greater, and maybe things like the feeling of that one is reliving the experience rather than just imagining it. So you would make a prediction that the subjective effect or impact of the real memories is going to be greater under LSD than placebo. But you would also make the prediction that the difference between the veridical memories, the real memories, and the phony ones will be greater still under LSD than under placebo. So in doing it this way, you'll be able to show that it's not just an effect on suggestibility or imagination. It's not just these things that are being enhanced, but maybe under LSD, the ability or the capacity to sort of relive experiences from one's past is truly enhanced. So you're including the phony memories as sort of controls. And this kind of thing has actually been done in dream research. So I was quite struck recently by a presentation I heard by some researchers at Swansea University in Wales, who tried to address this question of, can dreams facilitate emotional insight? And so they used a particular technique with the reporting of dream material. In their work, they used they used daydream material as the control condition, and they used these techniques of sort of talking through one's dreams as a way of sort of facilitating this process of novel insight. So they would do that with actual dream material, and they would do it with daydream material, and they found that with the actual dreams, there was more novel insight that occurred than with the daydream. So you could do something similar with psychedelic imagery and realizations, I suppose. You could treat them in a similar way. Just talking to you, trying to answer this question, is a sort of reminder of just how difficult a problem it is. But I don't want to give up on it, because I do believe that it's not insurmountable. There will be a way.
Oh, I don't think it's insurmountable either, at all. And so your idea, if I'm understanding, is to give people small doses of LSD, give a control group a placebo, and put people in a brain scanner and ask them questions from depth psychology about their mothers and so on, and see how their brains respond under the influence of LSD when they're in that state of heightened connectivity and hypercommunication between brain networks, and see if you can find out how that communication between the conscious and unconscious minds is happening. It's sort of a cross between a traditional depth psychology session and a modern fMRI brain scanning study, which also incorporates psychedelic drug trips. I think this could be a fascinating study, if only because it's building a bridge between what have been considered some of the more fluff fields, psychology and Jungian analysis, and bringing them into the realm of objective, data-driven hard neuroscience with brain scans and computerized analysis of brain connectivity. And it's interesting to think that psychedelic drugs could be a sort of bridge that helps us connect those fields of research?
I think it might. And you know, you have people like, I can't remember his first name, but I think he's called Varela, who's coined this term of Neuro Phenomenology. And he sort of makes the point that let's try and retain some of the richness of the subjective experience and the phenomenology before we look at how it maps on to the neurobiology. And I think that's very true. And, you know, if we think about just psychology in general and what we feel, you know, is important in our lives, if you think about someone in psychotherapy and the level at which they talk about themselves and, you know, in terms of feelings and emotions, why do we have to break things like that down to looking at photographs of people with different emotional expressions on their face, for example, in order to do some kind of neuroscience on emotion and the neurobiological underpinnings of emotion? I mean, it's such a crude way of studying these things, and it's so far removed from the lived experience and the true richness of experience and you know what we really talk about and value when we you know operate in the real world. And this is a classic challenge in doing this research with psychedelics, is that you want to, of course, you want to do the science right and you want to be robust, but you also don't want to do disservice to the richness of the experience, because it's that richness that makes the experience interesting and valuable and important, and makes these drugs interesting and valuable and important. And, you know, it's a bit like, you know, we sometimes joke that you've got an individual who's on 100 mics of LSD or whatever, and they've just experienced complete ego dissolution and a sense of union with the cosmos, and they close their eyes and they can see interactions that they and feelings that go back to their childhood. And then you put a piece of paper in front of them or a laptop and you say, can you do this, you know, NBAC paradigm, please? You know, and it just seems absurd. And like, what kind of data and what kind of, you know, how useful and meaningful is that data going to be? Because they're just on a fundamentally different plane. It's not really going to tell you anything at all, other than that they can't do it, and they're not operating, you know, even close to where we are in normal waking consciousness.
Oh, I felt the same way for a long time. Whenever I read older studies on LSD experiences or watch, you know, old interviews from the 60s with people on LSD, the interviewers are like asking them to do math problems or to describe the table or the chairs or what's on the walls. And these questions all just seem totally irrelevant to the nature of the LSD experience. Yeah, I just keep thinking, you're completely not getting it. You're not getting what it is that makes this experience so interesting and worth studying. You're not asking questions about the interesting parts of it. And so I'd love to see those kinds of questions asked more. You know, I'm also a history geek, and history all over the world is full of references to psychedelic drugs used in religious rituals and to the experiences that people had while they were on those drugs, which sound so bizarre and interesting. And I've always wondered, for example, in ancient Greece, let's say you're in a Greek mystery cult and someone says, I went into the cave and I ate the sacred mushrooms and communed with the god Dionysus. I want to know what the neural correlates of that were.
Yeah.
You know, what were the neural correlates of communing with the god Dionysus? What's that all about? You know, these experiences are so novel, so not analogous to anything in our daily lives or to the experiences produced by sedatives or other kinds of drugs. Maybe we need to be willing to be a little more adaptable in our approach to researching these drugs and the kinds of questions we ask, and really try to get our heads around the strangeness of these experiences and try to understand what's really happening.
I agree, yeah. And just to say that, a construct is abstract doesn't mean it's unworthy of research or that it's unscientific. It just means that you've got a big challenge there. It just means that a lot of work needs to be done to, for example, develop its construct validity. And we know of ways to do that, and they may be just subjective measures, or they may be supplemented by some interesting behavioral measures. So, for example, if you think that the ego isn't just a thing that's sensed or felt or perceived, but it's something that also has sort of behavioral implications. It's involved in certain functions, as in you need an ego to be able to do certain things. And if you come from, say, a Freudian perspective, and you say one of the ego functions is, let's say, reality testing, then you could look at something like suggestibility as a behavioral index of the intactness of one's ego, because you're looking essentially at reality testing. When you look at suggestibility, you might have a paradigm where an individual is being told that, that there are heavy books on their hand and they can't keep their hand up in the air. If one was in a normal, sober, waking state, you would be, who's this guy telling me that there are books on my hand? There clearly isn't. I know that. And so you have this very sort of strong hold on reality. What's what. Suggestibility could be used as an index of reality testing in this way. And so you can sort of flesh out and develop really constructs, even memory. They only really exist because of all the things that can connect with this construct of memory, and so therefore give this construct some construct validity. And it's the same for something like the ego. It's just that at this moment in time, psychology hasn't yet developed all these connections in order for it to feel like a really robust and recognizable and familiar construct. But that's one of the challenges for the future, is to try and firm up some of these admittedly quite abstract things at this stage. Yeah, so you do things like, you could look at the correlation between a measure of ego dissolution, like a subjective measure, and the degree of suggestibility. And you might predict that you would see a strong relationship there, that the more suggestible you are, the greater is people's ratings of ego dissolution.
And like you said, just because something is abstract or even supposedly fictional doesn't necessarily mean it's unworthy of serious scientific research. As in so many other areas, from engineering to politics to music, we can learn a lot when, with a rigorous modern scientific approach, we seriously ask the question, what if those ancestors of ours were really on to something? Well, Robin, I feel like I could easily keep talking to you for another 3 hours here, but this has been a phenomenal hour of conversation, so I won't take up any more of your time. I can honestly say that this has been one of my favorite interviews I've ever done.
Yeah, same.
I really don't know what I can add to it other than to say I hope we'll get to talk again soon. And I hope you'll get a chance to do your depth psychology psychedelic brain scanning study, because I, and I'm sure a lot of people listening, are really eager to see what you'll find out. Well, for everyone listening, I've got a lot more fascinating guests coming up on the podcast soon. And until then, have a great week, everybody. Go do some science!